Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. The number of compounds from the following which can undergo reaction with Br2 KOH alcoholic to give respective products, and these respective products can also be obtained separately by a Gabriel Thalamid reaction is. Okay. So these are some of the compounds given to us, and the chapters involved is amines. Okay. So let's say that this is A, this is B, C, D, E, and F. Okay. So the compounds given to us are all amides. You can see all of these are amides. Okay. So we should know that when a 1-degree amide is treated with an alcoholic solution of potassium hydroxide and bromine. Okay. When you have 1-degree amide plus KOH alcoholic plus bromine Br2, it gives a 1-degree amine. Okay, the answer is a 1-degree amine which has one carbon less than the original amide. So it will have one carbon less than this guy that we are starting with. Okay, so this is the famous Hoffman bromamide degradation reaction. Okay, we should know that in a primary amide, okay, so if you have a primary or a 1-degree amide, nitrogen is attached to one carbon. Okay, that is, for example, RC double bond O NHH. So this is an example of a 1-degree amide. As you can see, nitrogen is connected to one carbon. Okay. In a secondary amide, nitrogen is attached to two carbon. That is, for example, RC double bond O N connected to CH3 connected to H. So you can see in this case nitrogen is attached to two carbons. So this is an example of a secondary amide. And in a tertiary amide, nitrogen is attached to three carbon. That is, for example, RC double bond O N CH3 CH3. So you can see here nitrogen is attached to 1, 2, 3 carbons. So this is an example of tertiary amide. Okay. Remember, only 1-degree amide shows Hoffman bromamide degradation reaction. Very important. Only 1-degree amide shows Hoffman bromamide degradation reaction. Okay. Next, we have to talk about Gabriel Thalamid reaction. Okay. So, or the GP reaction. It cannot be used to make aromatic 1-degree amines. Very important. Cannot be used to make aromatic 1-degree amines. Okay, because the reaction proceeds like this. So we start with Thalamid. We react it with KOH, alcoholic, and then we get potassium Thalamid. Okay, benzene ring, CON minus charge K plus CO. So this is our potassium Thalamid. Okay, then we treat this guy with C2H5I and heat. Okay, in that process we lose a molecule of Ki and we get benzene ring, COCON, C2H5, and then we do the acidic hydrolysis of this guy, H plus H2O, and heat. In that process we get COOH, COOH plus C2H5NH2. So this is the amine. Okay, so you can see this amine is formed by the nucleophilic attack of C2H5I on potassium thiamide. So this guy attacked this guy. Okay, so if we had used an aryl halide or a haloarine like iodobenzene, so let's say instead of C2H5I, if I would have used iodobenzene, instead of getting C2H5NH2, I would have got aniline. Okay, so but the thing is, aryl halides don't undergo nucleophilic substitution reaction. That is, this guy cannot react with this guy because this guy cannot show nucleophilic substitution reaction because this is a haloarine. But haloalkanes can show. That's why it cannot be used to make aromatic 1-degree amines. Okay, so let's look into the compounds one by one now. So first compound A is C6H5 C double bond O NH2, or you can also draw it as benzene ring C double bond O NH2. Okay, so it's a 1-degree amide. As you can see, nitrogen is attached to one carbon. Okay, so therefore it will show Hoffman bromamide degradation reaction, and as a result of that reaction we get NH2 and benzene ring, that is aniline, as the product. But it cannot be obtained, that is this guy cannot be obtained by Gabriel Thelimid reaction because it is a aromatic 1-degree amine. So this cannot be obtained by Gabriel Thelimid reaction. Therefore, compound A is not correct. Okay, A is not correct. Then we will talk about compound B. So B is C6H5 CH2 C double bond O NH2. Okay, or you can also draw it like this: benzene ring CH2 C double bond O NH2. So it's a 1-degree amide as nitrogen is attached to one carbon. Okay, so therefore it shows Hoffman bromamide degradation reaction. Okay, and the product will be, we will get a amine having one carbon less. So therefore the product will be benzene ring CH2 NH2. Okay, and this product can also be obtained by Gabriel Thelimid reaction as it is aliphatic 1-degree amine. You can see nitrogen is connected to a aliphatic carbon. It is not connected to a aromatic ring. Okay, so therefore this can be obtained by Gabriel Thelimid reaction as well. So therefore compound B is one of the answers. It's correct. Let's talk about C. Compound C is CH3C double bond O NH2. Okay, so it's a 1-degree amide. As you can see, nitrogen is connected to one carbon. Okay, therefore it will show Hoffman bromamide degradation reaction, and it will give an amine having one carbon less, that is CH3NH2 as the product, and this product can be obtained by Gabriel Thelimid reaction as it is a aliphatic 1-degree amine. Okay, so therefore compound C is also correct. Now coming to compound D, which is C6H11 C double bond O NH CH2 CH3. It can also be represented as like this: C double bond O NH CH2 CH3. Okay, so it's a 2-degree amide. 2-degree amide. as nitrogen is attached to two carbons. So nitrogen is attached to one and two carbon. Okay, so therefore it does not undergo Hoffman bromide degradation reaction. Very important. Does not undergo Hoffman bromide degradation reaction because it is a 2-degree amide. Only 1-degree amide shows Hoffman bromide degradation reaction, and therefore D is rejected. Then we have to talk about E. Compound E is CH3 thrice C, C double bond O, NH, CH3. Okay. Again, it's a 2-degree amide as nitrogen is attached to two carbon. So nitrogen is attached to one and two carbon. Okay. So therefore, it again does not undergo Hoffman bromide degradation reaction and is therefore rejected. And then we have compound F, which is C6H11, C double bond O, NH2. Okay, or we can also represent it like this: C double bond O, NH2. So it's a 1-degree amide as nitrogen is attached to one carbon. Okay, so therefore it shows Hoffman bromide degradation reaction, and as a result gives this as the product, and this product can be obtained by Gabriel Thallamide reaction because it is aliphatic 1-degree amine. As NH2 is connected, it's not connected to an aromatic ring. So therefore it is a aliphatic 1-degree amine. So therefore compound F is one of the answers. Okay. So the total number of products or compounds from the following which can undergo reaction with Br2 KOH to give respective products, and these respective products can also be obtained separately by Gabriel Thallamide reaction is, so we have one of them as F, then C and B. Okay, so there are three of them. So the answer will be 3. Okay, thank you. I will mark them C, B, and F. Okay, thank you.